Hello everyone, welcome back. Let us discuss something very interesting today. So, how do you think the price of an option called the premium is decided? By now, you must know that the premium varies depending on the strike price. But how do we figure out the fair premium of the option? So, this is where the Black and Scholes model comes in. It is a mathematical formula developed in the 1970s by Fisher Black, Myron Scholes, and Robert Merton. It calculates a fair value of an option based on few key factors. So using these inputs, the Black and Scholes model makes option pricing feel more like a science than a guessing game. Let's look at the key factors that affect the price or the premium of an option. So these factors play a crucial role in determining how much an option buyer pays and why premiums vary. First, we have the current price of the stock. So this is a starting point as every option's value is tied to the stock it is based on. Next, there is a strike price of the option. Not all strike prices have the same premium. Options that are deep in the money are very expensive because they're almost guaranteed to have value at expiry. On the other hand, deep out of the money options are much cheaper because there is a very slim chance they will end up having value. Then there is the time left until expiry. So here's a simple rule. The more time an option has before it expires, the higher its premium. Why? Because more time means more chances for the stock price to move in favor of the option buyer. So this is called the time value of an option. Next, we also consider the risk-free interest rate. This rate affects the cost of carrying an option and plays a small but important role in pricing. Finally, there is volatility. This measures how much a stock price is expected to fluctuate. So higher volatility increases the chance that an OTM option could move into ITM option before expiry. And because of this, option sellers charge a higher premium for options on highly volatile stocks. They are taking on more risk, so they want to be compensated for it, right? So in summary, the price of an option depends on the stock's current price, the strike price, time until expiry, the risk-free interest rate, and volatility. So understanding these factors help us see why option premiums vary and how they are calculated. Now, the Black and Scholes model is built on a few assumptions. The first assumption is that the stock prices can't go below zero. So they follow what's called a log normal distribution. The second assumption is that the stock doesn't pay dividends during the option's life. The third assumption is the option can only be exercised when it expires, which works well for European options but not so much for American options. The fourth assumption is stock prices move unpredictably like a random walk. Fifth is that there are no transaction fees or hidden cost. It assumes a perfect market. And the sixth assumption is interest rates stay the same during the option's life. Seventh is that the market volatility doesn't change over time and stocks' returns are normally distributed. The eighth assumption is there is no risk-free way to make a profit and therefore there is no arbitrage. While the original model didn't account for dividends, modifications were later introduced to incorporate them. So this model was so groundbreaking that Myron Scholes and Robert Merton won the Nobel Prize in 1997 for their work. Sadly, Fisher Black couldn't be honored since the prize isn't awarded posthumously. So today, the Black and Scholes model is a big deal in finance. It helps traders and investors price options fairly and understand the market behavior. Now, let us get to the formula. So here the C represents the value or the price of the call option or the call premium. Put is the value or price of the put option or the put premium. S0 is the current price of the stock or the spot price. K into e to the power minus RT is the present value of the strike price, where R is the risk-free rate and T is the time left for expiry. and E is a mathematical constant like a multiplier used to calculate the present value. Don't worry about the math, it just helps us discount the future money. D1 measures the chance that the stock price will cross a strike price considering the current price, volatility and the time. D2 adjusts this by removing the effect of volatility over time. ND1 is the probability that the stock price will move in favor of the option buyer. So for a call option, this means if ND1 is close to 1, like 0.9 or 90%, there is a high chance the option will be profitable. If ND1 is low, like 0.2 or 20%, there is a smaller chance it will make money. ND1 focuses on the overall chance of the stock price moving in your favor at any time, whereas ND2 focuses specifically on the chance of ending in profit at expiry and after considering the interest rates and the time left. Now let us work on some real-time data using Excel to compute the premium for both call and put option. Let us take my all-time favorite stock, that is Tata Motors. The current stock price of Tata Motors is Rs 818. Let us check the option chain to find the available strike prices. So if you can observe, there is a difference of Rs 10 in the available strike prices. Let us choose an ITM strike for a call option, that is Rs 790. We also need other informations like the risk-free rate. For that, we can select the 364-day T-bill rate, which is at 7.15%. Then let us check the annualized volatility of Tata Motors, which is around 35.15%. For the time to expiry, the last Thursday of December, that December 2024, is 26th. So today's date is 7th December, which means we have 19 days to expiry. Now that we have all the required information, let us compute the fair value of the call and put option for the 790 strike price. First, let us compute D1. Before that, we will require the present value of the strike price and the standard deviation square by 2 for further computations. So let us keep that handy. So I have split the formula to compute D1 into 3 different parts. First, let us calculate ln of spot by strike, which is 0.0348. Then we need to compute R plus standard deviation square by 2 into T. Since we already have the standard deviation square by 2, plugging in the values become easy. So we get 0.0069. Then let us compute standard deviation into square root of T, which is 0.0802. Now, let us use all these 3 values to compute D1, which is 0.5208. Now, let us move on to D2, which is standard deviation into square root of T. So, we get 0.4406. Let us move on to ND1. To get the Z value, we can use the NORMSDIST function in Excel. ND1 is 0.6987. Let us similarly find the ND2 value. Now, let us finally compute the fair value of the call option, which is spot price into ND1 minus present value of strike price into ND2. We are getting the fair value as 44.04. If we compare that with the market price, it is Rs 39. So is it worth buying the call option at 39? Yes, it is, as the market price is less than the fair value. Now let us compute the value of the put option using the put call parity formula, as we already know the value of the call option. So value of put option equals value of call option or the call premium plus the present value of strike into e to the power minus RT minus the spot price. So we get the fair value of the put option to be 13.11 rupees. Again, if we compare this with the market price, which is just Rs 7, so it is definitely worth buying. Now, do you observe for the same strike price, the call premium is more than the put premium? Can you guess why? This is because 790 is an ITM strike for call option, but it is the OTM strike for put option. I hope this is clear. Now let us also verify our computations with the the Black and Scholes calculator. Wow, our values are exactly matching. So our computations are absolutely right. So you can also try this for any other stock of your choice. The Excel file will be shared with you. You can use the same template and try with any other stock and verify the fair value with the prevailing market price. Thank you. Hope you found this session useful. See you in the next lecture on the binomial option pricing model.